I'd like to believe that it's like quite a human thing that we all want to do one or more things well. And certainly for me, I spend a lot of time writing software. So like a warning here, this presentation talk was originally aimed at developers, so lesser beings than you guys. Treasure is but I hope you find some value in it. So I spend a lot of my waking hours writing software, so I'd like to do it well. In fact, I'd like to think that I write quality software. And if you apply my confirmation bias to job ads, you'll see that other people also really like quality software. Quality really matters. Write high quality code, production quality code, ship high quality code. And if you look on the back of one of these nifty Cape Town testing shirts, what does it say?
Everyone wants.
There we go, thank you. So we all care about quality, we all want to build quality software. But the problem was, like after a while I realized I don't actually know what that word means. I mean, I know in general, right, it's like a warm and fuzzy, but for something that's driving what I do on a daily basis, I really don't feel that comfortable with what it means and what it means to me as an individual. So when I started writing software, I mean, the first few years of any developer's life is really just trying to figure out why computers hate you. And then after a few years in, you suddenly realize that you just have to deal with the fact that computers hate you and you try to make things better. And so in the context where I spent a lot of my formative years as an agile dev, I came up with like quite a narrow view of what quality meant. And so the fact that it was narrow didn't mean that it was well defined or objective. It was like super subjective. But it worked for me in the context that I was in. And then things changed. I left the context I was in and I started consulting to a number of organizations with varying degrees of ambition and varying degrees of money. And all of them had formed different views of what quality is in terms of software. And some of these views were contrary to mine, and yet they seem to be working for the organization. That obviously, because developers are always right and they never break anything, that just couldn't happen. So I had to take a step back and think, well, how can people be doing stuff that's radically different to mine and still be producing results? So that must mean that my view of what quality is probably a bit suspect. So for me as a developer, quality means structural quality. And structural quality for software is like all the buzzwords, right? Reliability, efficiency, security, maintainability, size, where in this case, size is the smaller the better. And so that was like that felt quite comfortable. I was happy with that, and if I looked around, there were a lot of people a lot smarter and a lot more experienced than me who agreed. Martin Fowler says that reducing internal quality slows us down. Uncle Bob says that delivering function at the expense of structure is a fool's errand, except he does it like this American accent, which makes it sound a lot more impressive. And at the same time, in the last 10 years, we've seen the rise of the software craftsmanship movement, which is a group of people striving long and hard to try and get people to write better software, and hats off to them. So that all feels like, internal quality. I'm still on a safe wicket here. I haven't completely lost my mind. But even within that sort of narrow definition of what quality is, you get a difference of opinion. So I'm going to take something safe, like unit testing, right? Everyone does automated testing, and we all try and get as much coverage as possible. Exhibit A. So Kent Beck, if you don't know him, is the guy who wrote JUnit, the first mainstream unit testing framework. Sadly, it was written for Java, but we can't be perfect. He says he tests as little as possible to reach a given level of confidence, and if I don't make a kind of mistake, I don't test for it. Now that already, I think that was 3 or 4 years ago. It set the internet afire because, seriously, Ken Beck probably doesn't make a lot of mistakes, but for everybody else, that's bad advice. Uncle Bob pitches in with unit tests should provide as close to 100% coverage as is possible. So there already is our first what the fuck moment. There's a big discrepancy between those two. And then we have Michael Phillips, less well known than the previous two, wrote a book called Working with Legacy Software. If you're dealing with legacy software, I highly recommend that you read it. He says that legacy code is code without tests. Now for me, the thing I'm not going to put on my LinkedIn profile is that I spent 6 years at an organization increasing their legacy code footprint, right? So Michael Feathers reckons he's more in Uncle Bob's camp. And then this was a discussion, I think it was about 3 or 4 years ago now. So the guy on screen is a guy called David Hannemeyer Hansen. And because he has a name like that, everyone abbreviates it to DHH. He's the founder of Ruby on Rails. The little picture on the bottom right is Martin Fowler of ThoughtWorks, and then we have Mr. Beck again. And they have a series of, I think it's still on YouTube if you go looking for it, discussions about what TDD is and how it should work. And it stretched on, I think, over a number of weeks, and they never actually came to like an absolute conclusion. And that's what happens when you get 3 devs in a room, you get about 5 opinions. So within all of that, you sit back and you think, well, these are all guys who are leaders in their field. They're respected. They manage to publish a ton of books. People look up to them. They must know what they're doing. So how can we get such a broad range of differing opinions? How can all of these people be right? And so the thing that struck me, it always is like obvious after the fact, is that context is like really critical. We had context nicely introduced by the speakers before me. But every place you work has a different context. No 2 contexts are the same. You've got different members in the team, different experience levels, different rates of attrition in your team, you've got different amounts of money, you've got different market positions. All of those things feed in. And yet what we do is we try and take a standard way of doing things and apply it to wherever we go. This is what quality software looks like, regardless of if I'm at Alan Gray or at another customer or somewhere else. It must all look the same. This is how you write quality software. And we don't factor in the skills of the people on the team, how much churn is happening there, how fast the stuff has to go out to market, how mature is the product. And a lot of that, when you take a little soundbite, and I've done this a lot, generally I've either gone to look in a book because I want to solve a problem, or the worst yet, I've read something in a book and gone looking for a problem to apply it to. But we apply it without context. We don't try and consider what Uncle Bob was basing his theory on about 100% coverage for tests. Which is valid under some context, as is Kent Beck's. You'll not be surprised to know that they're not the same context where they apply, they're radically different, but both valid statements. But the problem that that I find in personal experience, I'm not going to sort of tar you with the same brush, is that very often that context isn't made visible. We don't really think about what our context is versus the context of whatever approach we're going to put in place. We'll take it, we'll maybe print off a few copies, and we'll try and apply it without applying perhaps as much thought as we need to. So for developers, we have quite a, wow, that's really a crappy shadow thing. We have quite an introspective view of quality. And I think to a degree, the testers I work with suffer from this, but definitely developers. We can control the quality of the thing that we build. So that's internal quality. We feel super comfortable about that and fine-tuning it and tweaking it within an inch of its life. But that's often not the best thing to be doing. And so now, I believe that structural quality of software is critical. Eventually, you can ignore it for so long, and eventually it comes along and just eats your lunch. And so, it is vital. You can't ignore it. Eventually, you have to approach a really good level of structural quality. But sometimes, focusing on structural quality is not always the most appropriate thing you should be doing. Sometimes there's other things that are more predominant and should be focused on first. And structural quality can take a back seat for a while, which is madness, to quote the gentleman in the back. So Dan North says, apply the appropriate amount of rigor, discipline, and excellence. So that's a bit of a clue. He's not saying go completely religious on this thing. Maybe there is space in this sort of wiggle room. And so you remember Uncle Bob, previous 2 slides have been quite sort of black and white. Uncle Bob says no professional developer should ever follow a discipline when that discipline does more harm than good. So even Uncle Bob, who's a dyed-in-the-wool Republican, I'm pretty sure, he needs this wiggle room to say, hey, you've got to use your judgment. You've got to make a decision. So at this point, I'm going to touch on what I think is perhaps a better definition of quality than using it just as a broad, encompassing thing of good software. Quality is an essential or distinctive characteristic, property, or attribute. So perhaps as software professionals, our job is to optimize the appropriate qualities for the context that we are in, rather than just treating it as a blanket statement for good software. And the best way to see what is appropriate is to perhaps look outside of the team that we're in. So if you're an analyst, you're already doing it, but if you're one of the lower forms of life, such as a dev or a tester, then that takes a bit of work for us. Especially if you don't like people, the way I do. So I'm going to give a couple of scenarios where perhaps internal quality isn't the most key thing to be thinking about at a particular time. So sometimes you'll be in a situation where your organization wants to reduce opportunity cost. So the opportunity cost, if you never heard the term, is sort of like FOMO for businesses. While the team is building one thing, it can't be building the other thing, and the accountants and bean counters stress about how much money they're potentially losing. So one way to approach this is something called deployed is not done. So when I started with Scrum a long time ago, done was quite a key thing because people used to fudge what done was. They'd say the thing was basically done, when basically is a modifier which means anywhere between 1 and 99%. And you'd have stuff that wasn't done and it would get out. And then it sort of became a thing, well, you can't deploy unless it's done. And what we're seeing is some people are reversing it and saying, it's okay to deploy before it's done. And the thing you're building, the quality you want to build in is the ability to roll out the software incrementally in a reduced form. So if you're building something with a web interface, and the web interface is going to be all reacty and super expensive and shiny and flashy, and that's going to take a lot of time, perhaps you can give the users a command line interface in the meantime. You can put it out there, you can validate the functionality, they can try it out and find all the bugs that you swore weren't there. And in the meantime, you build on the front-end interface, or you build on something else while you're waiting for the feedback. So you can switch tracks a little bit and perhaps make the business feel better about all that money they're not making. And the next is something that's Dan North and Liz Keogh called high learning projects. So a high learning project is anything where there's a high degree of second order ignorance. So second order ignorance was summarized by Donald Rumsfeld as the unknown unknowns. And pretty much any project you're building, there's unknown unknowns. There's stuff you don't even know you should be worrying about, and that's the stuff that's going to come and bite you, and you want to build as little as possible on top of that foundation as you can. And what Dan North suggests, and this approach is super contextual, and I'm not going to try and sell it in the time I have. It's worth reading up on because it's scary. Calls it spike and stabilize. So spike in this context is very much similar to the Scrum meaning, which is a prototype sort of code. Except whereas in Scrum, what you usually do with the spike is you throw it away. In spike and stabilize, you put that prototype into production. So you build it as well as you can. You don't put any tests behind it. You put a minimal amount of effort in terms of engineering quality. You put it into production, and you see if it works. And you see if it's providing value. If it's not providing value, it disappears. And if it is providing value, then you set up a trigger for when you're going to stabilize. So the examples that Dan North will give you, sometimes you'll set up a trigger when you are going to have new members joining a team and they're going to be working on this code. One of the original authors is leaving, or you need to go in and fix a bug. And at that point they'll do stabilizing. And stabilizing is about lowering the cost of change. So that is about maybe adding documentation, adding tests, refactoring, higher level of extracting stuff out into more general methods. And Liz Keogh, who admittedly is biased because she's behind Spike and Stabilize, said the skill to stabilize later is more important than the skill of keeping the cost of change low up front. So just in background, Dan North, if you don't know who he is the guy who developed a lot of BDD and TDD principles while he was at ThoughtWorks. And he developed Spike and Stabilize while working for a trading company where they basically write software to make money like milliseconds faster than the next company. This was an approach that blew his mind and apparently works quite well for them. And finally, something that's gained a lot of vogue lately is lean startup. Like the last 10 years, we've seen the rise of the lean startup and almost a sub-narrative in that they don't write tests because it wastes too much time. I'm not going to argue that right now, but one of the things that Eric Ries, the guy who wrote the Lean Startup book, he says they take full advantage of the options, even if they feel dirty or riddled with technical debts. That's not a job, that's not what I see on my performance evaluation. If Rory writes stuff that's dirty and riddled with technical debts. But it works for them. And the reason it works for them is because they're taking a bet that some of the technical debt will never need to be repaid. In the Lean Startup, the idea is to try and understand as much about your market as possible in a short amount of time as possible. So they're hoping that some of the crappy code they wrote will never make it into long-term production, will disappear, and no one will have to worry about cleaning up a 2,000 line method. So what this talk isn't is a like carte blanche for developers to write crappy code. I think if you're going to do this, you do it deliberately and with thought and with like, collaboration with your stakeholders and people in the team and testers, the devs and the analysts. Because you want to choose your battles, you want to choose when you're going to put that bad code in place, and you must know what you're getting back for it. It's not about throwing code at the wall until something sticks. And to do that, you need more collaboration. So some teams, I think some industries have this already. Most of the places I've worked at haven't seen it, but it needs much tighter collaboration between the business and the devs. And to get that, you need a common language. So if I'm going to ask an analyst to compromise on a feature that he wants because I need to put in fancier code, I need to be able to explain the benefits of spending that extra time to him in terms that make sense to him.
English.
But with all the dialects that we have of English, there's variations. So Eric Evans wrote a book called Domain-Driven Design, which is about 1,500 pages, I think. It feels like 1,500 pages when you open it up. But he talks about a ubiquitous language. There is a standard language that's understood by everybody. That's the kind of thing you need here. And you need trust. If I'm going to compromise on something that's important to me, I need to trust that that person is going to give me an opportunity later on to come back and make it better. And so finally, what I've told you here is really not anything that's groundbreaking, right? You'll see I've pinched a bunch of quotes from people smarter than me. But yet, I found, so I still don't do this. I like to think that I think about the context every time, but in reality, when it comes to consistency, I suck. And so I don't do it as much as I would. But I think my one parting shot would be, if you're in a space where your focus is just sort of structural quality, sometimes it's worth taking a step back and just having a look and saying, well, is this the thing we should be doing right now, or is there another quality that we can be focusing on? And that, so because I can't resist, I'll leave you with one last quote. Here's my talk. Are there any questions? No, see, that's what I say. So you ask a question, I say it depends, and I can hear it. Excellent, thank you very much.